Thanks for tuning into this video. If you are here because you've had a look at a previous video of mine that was done a little while ago now, here we can see the YouTube link. It was done in 2012. If you're one of the 4,000 odd people that had a look at this, you might be one of the 1,000 people that emailed me about how to make the formula work, and that's because it was very complicated. So what this video is all about is trying to simplify that process of creating a radar chart and what you might do with them. Also want to refer to a blog written by Mladen Jovanovic on complementary training, where he quite rightfully says that spider charts suck, and this one indeed does suck. What he talks about is that there are some better ways to visualize the information, and we'll have a look at some of those today. But first and foremost, let's talk about these charts. I call them radar charts, and see what the processes are to really try and get it up and running. So typically what you do is use radar charts to indicate some kind of profile. And let's see a good example. We've got 6 different physical measurements here, and you might think that that could be a useful profile. The problem is that if we try to put them on a radar chart, you see up here on the Insert tab, there's a whole section for these types of charts, and we could choose one of them like that. We can see that it's really a mess, nothing useful out of that whatsoever. The reason for that is that the scale is different for all of these tests. Some have very low numbers, 13 for the functional movement screen, and some very high mid-thigh pull. So there's absolutely no way you can put that on a chart because you can't individually scale each of the points on the chart. They all have to be on a common scale, so you definitely need to figure out some way to do that. You can do some kind of banding process. You could do a Z-score, or you could do some other conversion. I'll talk about all three shortly. Another huge problem with radar charts, and it's definitely something that I avoid building for people unless they're really adamant that that's what they need, is that if you have missing data points, then the chart just melts into a puddle basically. It's pretty much useless. So you need a complete data set to make the radar chart complete. And part of the reason why video number 30 was complicated is because it had a lot of different scenarios covered. Missing data above or below a certain level, and a positive and negative scaled score. So it was certainly too complex a formula to really make it easy to understand. Now, I talked about ways to scale. There are 3 ways, and let's talk about the first one here before we go on to some more specific examples further on. Just drag these 2 out the way, drag this logo to the side, and if I can, there we go. I made this little table here. So I'm going to go through now and just manually, I'm not going to use a formula, although I would ideally set it up with a formula obviously, but manually I'm going to go through and say that 1880 on the yo-yo will get you level 4, counter movement jump of 69 will get you a 4, that's a 5, that's a 2, 190 will get you a 2 as well, and 150 will get you a 3. So we've now got a banding, and if we selected that on the Insert tab, selected a radar chart, we'd actually get something happen here. I'm going to delete that and start again. And the reason I want to start again is that even Excel doesn't like you using radar charts, and the reason I know that is because if I click on the Insert tab, there's a big button here in 2016 called Recommended Charts, and if we open that up, we can see that there's no radar chart to be seen, and in fact it suggests a column chart, a bar chart, a couple of different line charts, and even a pie chart. I think that's the wrong choice, but those first 4 options are all much more sensible, and it even explains why. Used to compare values across categories. So, but we could, if we wanted to, go ahead and find the radar chart, and build it. So let's click on radar chart. I'm going to choose this particular one here, maybe with markers, and say OK. Put it over my data for a second. I don't like how this looks. I would immediately be wanting to change that. And one of the things I'd want to change would be to put the cross lines in there. Now, on none of the style options up the top here, it allows me to do that. And so again, that makes me think that even Excel doesn't want you using this chart. And when I muck around with axis settings and things like that, it doesn't always give me the opportunity to put lines in. So I've often spent time trying to figure out how to do this, and I went online and I did a bit of a search, and what I found was that if you change the chart style to this one, then they'll come in. Then I'll change the chart style back to the one that I wanted, and the filling disappears, but the lines stay. They're the wrong color, but at least it gives me a chance to now go in there and make it grey. And so I do like that a lot better. If I make the grid lines around the concentric circles or hexagons, then it's much less busy now, because those grid lines are just faint and they're a lot easier to look at. So what would I do now? I'd select the data, I'd add my labels in, and I'd look at that and say, okay, that is an acceptable radar chart. The only reason that that works is we've got a complete data set, and we've now got everything on a consistent scale of 1 to 5. Oftentimes when you're looking at a data set, it may well be qualitative, so that a coach has evaluated a player based upon a bunch of different characteristics, such as these 6 here for football. And so I can select that. Once again, on the Insert tab, click Radar Chart. Always like making it a bit bigger. You can see here we've got a little bit of editing to do, so I'm going to format the axis, make sure it goes up to 10, because these are 1 to 10 scale. I'm going to also make it a bit bigger so that there's less busy grid lines on there. And the other thing, if I just get rid of that, change the chart type. Now that we've changed that chart type, format the axis, and on the line choose solid line. Finally, go back and change it to that. So I don't like the fact that you have to go through such hoops to make it look how you like. So once again, we've got a profile. What you typically would do is add a second set of data. So if I select data, add a new one, I've just called it data 2, and there are my values there. I've now got a second set of data on there, and we're able to get some information from that to show that on the left hand side, which is movement and passing, they have had an improvement. This is assuming that we've got the same player on 2 separate instances, but on the right hand side they've got worse, and as well as at the top and the bottom. So you are having to look a lot harder to make those inferences in comparison to if you did this. Simply inserting a bar or column chart, where without really a lot of effort, this is telling me very clearly that in 4 out of 6 categories, data 1 was superior, and in the last 2, passing and movement, the data 2 was superior. So that's why I believe that you can get more information from different types of charts. Let's go down to one more example here, and this is a real, I guess, classic example of why you shouldn't do a radar chart. There is 18 items here. Once again, they are qualitative assessments of a player's capability, or it may have come out of a statistics system from match analysis data, but let's just try creating a radar chart with that. If we do this one, I won't bother with those cross lines, but you might want to have a go at this. But you can see that this is just so busy, and the only way to really see anything is to make it really quite big. Once again, I could, if I wanted to add a second data set on there, and therefore you're sort of trying to unpick what's actually happening, and I just don't think that you get enough information from that. I've seen a couple of instances where they've used right hand side of the body on the right and left hand side of the body on the left to evaluate things such as knee function and lower body function and so on. Yeah, possibly I could see how that might be useful, but I still think there's probably better options out there. Let's go to a example sheet. That was one way of doing a scale, but the most normal way that you hear people talk about is the Z-score. If you don't know much about Z-scores, look it up. I'm not a stats expert, but Z-scores are basically saying, where does your score fit within a population? And so if you've got a team of athletes, that's your population. You want to give athlete feedback as to where their score or where their profile sits with regard to their teammates. And if I just delete out the Z-score for the yo-yo, we can go through the process of creating it. Below here, here's our data set. You can see it's a perfect data set. There's a score for everyone for each test, and we've got yo-yo results in here with a mean and standard deviation at the bottom. That's all you need to do a Z-score. And if I just start typing equals STA standardized, pops up, that is our Z-score. The X is your value. I just have to use my arrow keys to get to it. What is the mean? Well, I've calculated the mean down the bottom, and I've also calculated the standard deviation down the bottom. So it's all just sitting there, and all I have to do is put it in, and there's my Z-score, and it's pretty easy stuff. If I select a different athlete, you can see things are updating, and the reason I did that is because I've pre-drawn a whole bunch of charts for us to look at as a comparison. Now the Z-score basically gives you an indication as to whether you are above or below the mean, and how far above and how far below the mean you are. So positive scores are obviously better, higher Z-scores are obviously better, but a problem that I do have is that unless your population is truly representative, then sometimes what you can do is have a person with a fairly modest score still get a high Z-score because they're in a population that doesn't do very well on that test. When I'm working with athletes, I'm always sort of seeking improvements and trying to use potentially international benchmarks to identify that a certain level of fitness or strength is appropriate for an athlete to be seeking out. Now, the my score, I just called that my score for now, is really a way of representing that. It's a little bit like the example I showed at the beginning where we've created a benchmarks table. I just made these numbers up. You can make whatever numbers up you like if you're going to do that kind of banding system. So this is just giving a little bit more granularity. Rather than saying you've got a band of 5, it's giving you an exact score, which indicates where exactly you sit on the continuum between minimum acceptable and target. And so for those calculations, I basically made up some numbers. That's what these grey numbers are. What is the minimum acceptable yo-yo score for an athlete on my team? That minimum score is 1500. My criterion, my target is 2600. And on the basis of those two, each unit is 11 points. So all I have to really do is a fairly uncomplicated mathematical equation that tells me whereabouts on the continuum between 0 and 100 does 2520 fit. Obviously it's very, very close to the criterion end, so a score of 93 immediately makes me think that that's right. I've done the calculation correctly. Whereas a counter movement jump of 50 is exactly 10 points up from the bottom out of a scale of 40. So I can do the maths in my head and know that 25 is the correct score. So really what it's doing is whereabouts is that score. Now this is a contrived data set, obviously, and one of the things that's very important to understand about this one is that all of these tests are positive. I don't really know exactly what the right terminology is, but basically what I'm saying there is that the higher the score, the better. And when you start mixing up your test measures in a radar chart or any kind of analysis, you have to be very wary what might happen if you do a reverse. So if you have a speed score or something like that where a lower score is better. Now, it's definitely worth thinking about. If I put speed down here, let's say 10 meters, I'm going to write a formula called ran between. Ran between, let's say the minimum score is 1.7 seconds and the maximum score is 198 seconds. If I divide that by 100, it just gives me a random score that'll do just nicely for our example. Drag across these mean and standard deviation formulas. Tidy it up slightly. I can now do something with this. So we've got some example data, and if I change my mind up here and said speed 10 meters, and so if I change that to speed 10 meters, I have to modify this VLOOKUP. Firstly, I have to drag this across so it knows that it can look in the table, and speed is now column 8. So just a quick little edit there. Now we can see that we've got negative 98 now because we haven't adjusted these zero and criterions yet. So if someone ran 2 seconds, I would say that that's worth 0. And if someone ran 1.65 seconds, I would say that's our criterion. So because this units becomes a negative score, the my score automatically calculates. Let's choose a different athlete and see if it does what we think it should do. 1.81 is about halfway between 2 and 1.65, therefore it gives us a score of 54. That looks good, and so does that. So 10 meter time, what you have to just be careful of is that criterion and zero score. You need to get them the right way around so that they don't mess up what that my score calculation is doing. So let's say we've got our data, we're happy with it. We could go in lots of different directions and create charts of different kinds. There's one more thing I need to do, just because the Z-score thing's a little bit all over the place. I just need to realign the workings of that Z-score to the 10 meter time. There you go. So if I just zoom out a bit, what we'll see is Z-score plotted on a radar chart, Z-score plotted on a line chart, Z-score plotted on an area chart, and I've gone a bit all over the place, sorry, but Z-score plotted on a column chart and a bar chart. Did exactly the same thing using the my score concept. You can see that the Z-scores go from negative 2.5 to positive 2.5. You'll make your own scales up for that, but that's what I chose. And that the my score is 0 to 100, obviously. So really what it's trying to show is that both of those two kind of give a similar shape, and it's only your personal preferences that will determine which one is the best option for you. If we go over to a themed data set, there's a couple more things to talk about. So what I mean by theme is that in this case, all of the 6 tests that I've chosen are kind of for a similar quality, and I've seen people do quite nice radar chart reports for things like jump testing, where they're looking at half a dozen different variables for lower body power, and on a radar chart you can actually look at the shape of the trace to give you an indication as to what a person's capability is. If we look at the Z-score chart immediately on the right here, I'm just going to drag it across. Chris Jackson has got, by looking at this chart, we can see not a huge amount of strength, but a reasonable amount of power. Much more shape is on the right hand side of this chart than on the left. Whereas if we switch to a different athlete, we can see that we've got a different shape appear. So that's why there is still some popularity for radar charts, because this kind of shape concept provides at a glance, a good indication of what an athlete's qualities are. Now, the problem that you have with shape is that if you don't get the sequence of the tests right in your data table, then the shape's going to be completely random. So the way I've set this up is I've got the 2 strength tests last, squat and bench. I've got the jump tests pretty much at the top, and I've worked my way around. So if you change the sequence of those tests, the shape's going to look quite different, and therefore you really can't rely on something as simple as looking at it to give you a good understanding. And the same process is really what I've gone through here for those 2 tests as well. We've got Z-score and my-score on radar, line chart, area chart, column chart and bar chart. Haven't done any formatting on these charts, so this is pretty much straight out of the box and fairly ugly in most cases, but I just get the feeling that you could customize these charts a lot better than you can the radar charts. So thanks for watching. If you want a copy of this file, please let me know. What I do recommend you do is get a good feel for what type of scaling you might want to do. So whether it's back here on the first sheet, a benchmarks table, you could set up a nice little lookup function that would automatically band the results for you. And banding players is quite easy for them to understand as well. If you do that, if you've got big samples or lots of data, you might prefer the Z-score. And if you want to play around with your own ideas and set your own benchmarks, then sometimes that my-score concept is also worth it. But really all you're trying to do is to put every test result on the same scale, and therefore a radar chart is possible. But just before I take off, I just want to demonstrate how perilous the radar chart is. And I'm going to do so by deleting something from Dwayne Baker here. So a mid-thigh pull from Dwayne Baker has now been deleted, and if I select him from the list, we can see how bad those radar charts now look, a complete mess. So any missing data causes huge problems, and it's very rare that you get complete and full perfect data sets. Now, I have created systems for people in the past where if there is no data, you use the previous data point. But again, that starts just getting messy very quickly. So missing data is your worst enemy when it comes to radar charts. So again, another reason not to use it. But if you do it right, they can look okay and be a useful tool inside your dashboard. Thanks for watching.